बस एक सेकंड देना, रिकॉर्ड भी हो जाए साथ ही साइमल्टेनियसली. Okay, done है. अच्छा, so we're going to start, and I'm just going to quickly open the data booklet. चले, let's start with the first one. Okay, let's start with the first question. The first question is about oxidation states. उसने कहा which compound contains two different elements with identical oxidation states. So it's probably going to be the first one क्योंकि H is +1, Cl is unknown, X, oxygen is -2. अगर इन सारों को you add them up, the overall charge on the molecule is 0. तो X की जो value निकलेगी ना, or X, I'm taking X for Cl. H is it's mostly +1, except for metal when it's with metals, and oxygen is mostly -2, except in peroxides and या फिर वो अगर fluorine के साथ bonded हो. So if you solve this, X would come out to be +1. So Cl over here is +1 and H is +1. वो वैसे ही +1 है, it's always +1. The next one is for the element sulfur, which pair of ionization energy has the largest difference between them? So if I pick a sulfur atom, it's got 16 electrons, ठीक है? So it's, and then it's got 8 electrons, and then it has, just 1 second. And then it has 6 electrons. Can anyone tell me which ionization energy, after which ionization energy would you have the greatest increase? Anyone? कोई भी जरी, any idea?
6th.
After the 6th one, removing the first, second, third, fourth, fifth, and 6th electrons would be easy because they're very far away, and the shielding is also large. The 7th electron is removed from an inner shell. तो अगर आप inner shell से remove करोगे तो वहां पे there's going to be a jump. So 6th and 7th. After the 6th, the largest difference between the 6th and the 7th, that would have a larger jump in ionization energy. And that would indicate कि shell change हो गया because now the electron is much closer to the nucleus. उसके बाद है which ion has both more electrons than protons and more protons than neutrons. So remember, the quick way to solve this would be that it has more electrons than protons. So that means it's going to be a negative ion. Only a negative ion is going to have more electrons than protons. So ye wala, that's gone. That's not an option. So we're looking at D-1, OD-1, OH-1. The other thing is it has to have more protons than neutrons. Pehli wali baat, to that applies to all three. Now we're just looking for this one, whether it has more protons than neutrons. So hydrogen over here has 1 proton and it's got 0 neutrons. So the element baki jo do hai na, the deuterium atom, that will have 1 proton and it will have 1 neutron, and oxygen will have 8 protons and 8 neutrons. So if the atom has oxygen or deuterium, then the protons and neutrons would be equal because they both have equal number of protons and neutrons. So it has to have H in it. So the answer would be D. You can either take the longer route and you can try and calculate the proton, neutron, electrons for each one of them. That would be time consuming. This only indicates that it's a negative ion, more protons than neutrons. That means it has to have hydrogen in it because that has more protons than neutrons. So that's why your answer is going to be D.
Sir?
Yes.
Just
yes.
Can you explain for the D part again? Like you were saying about hydrogen, it should have hydrogen. I didn't understand that part.
क्योंकि वो कह रहे हैं कि the molecule must have more protons than neutrons, right? So
yes.
if it has deuterium, ये वाला D जो है, if it has that, तो उसके अंदर क्या है? It has equal number of protons and neutrons, right? 2-1. One proton, one neutron, right? If it has oxygen, so it will have equal number of protons and neutrons, 8 protons, 8 neutrons, right? So उसने कहा था the molecule must have more protons than neutrons. The only way that's possible is that if it has hydrogen, क्योंकि hydrogen has no neutrons, so it has more protons than neutrons. तो वो जो भी formula होगा ना, it must have hydrogen in it.
Okay, sir. Thank
ठीक
you.
है.
Yeah.
I mean, this is the shortcut. Okay, the longer route is you just try and calculate the proton neutrons for each one of them. That's going to be too time consuming. Okay, you just have 1.5 minutes to answer this question. So next one is, okay, which ion contains the smallest number of electrons? That this is easy. Like I mean, this one will have 2 electrons. Let me write. The boron is 5. Beryllium is 4, I think. Hydrogen is 1, and helium is 2. So this one will have, I think it's going to be D. It's going to have just 1 electron. Hydrogen -1 will have 2 electrons. Beryllium 2+ will also have 2 electrons, and beryllium 3+ would also have 2 electrons. So it's going to be helium. अच्छा, अब आ जाते हैं, where's the 5th one over here? So now the 5th one is your basic O-levels question, which is, okay, you've got the reaction has an activation energy of 5.4 and it's an exothermic reaction. So for an exothermic, all of them are actually exothermic. The products is going to have a lower energy compared to the reactants. They're losing energy. So they're all going to be exothermic. And delta H, first thing, all your arrows, they start at the reactants. Okay, so I think that would make B as the correct option, because remember, all your arrows, they're going to start at your reactants. Enthalpy change is the difference between the reactants and the products. Remember, the arrow is going to start at the reactant. Activation energy is the energy that is initially needed to start the reaction. So you need to break the old bonds. So it would be energy that would be needed right at the very beginning of the reaction. So that would be activation energy. So I think this kind of fits the description, but let's check what's wrong with the other ones. The activation energy is 5.4, the enthalpy change is minus. So I mean, this one is wrong, the arrow is wrong. This one, what's the difference? D is the one, just 1 second. D is the one that's correct. Because over here, the delta H arrow is from the top to the bottom. All the arrows, they start at the reactant. So your D is the correct one, because the arrow is starting from the reactant. Okay, remember that. All arrows are going to start at your reactants. Now, next one is bond angles. It's about bond angles. So one by one, I'm going to do that, starting with just one second. Let me. Just a second. As I starting with this one, which series shows the molecules in order of increasing bond angles. So we're going to calculate bond angles for each one of them. The first one is CH4. That is going to give you a tetrahedral arrangement where the angles are 109.5 degrees. The next one is BF3. BF3 just has 3 bonds. Make sure you count the lone pairs. Boron will not have any lone pairs. Why? Because boron just has 3 electrons, and all 3 of them are bonding. So there's no electron left. That is going to be fan-shaped, and the angle in that case would be 120 degrees. Then you've got NH3. NH3 is like a tetrahedral shape, except that the top side is missing. Instead of having an atom on the top side, there's just going to be lone pairs sitting on the top. So there's nothing on the top. So it's like a tetrahedral with the top missing. So it's like a pyramid. It's a pyramidal shape, and the angle would be 107 degrees. And because the lone pair, the angle would have been 109.5, but the lone pair has a greater repulsion. So all the other bonds, they kind of get closer to each other. So the first one is 109.5. Then you've got BF3, which is 120. And then you've got NH3, which is 107. So that's not going to be correct. The other one, remember CO2, just 2 pairs of bonds. So that's 180 degrees. You've got water. Water is also derived from a tetrahedral shape, except that in water you have 2 hydrogens. And on the other 2 sides, instead of an atom being bonded, they're just lone pairs. Oxygen has 2 lone pairs. So there's nothing there. So this is going to be a bent shape. It's just going to be V-shaped or bent or non-linear. And the angle, because of the extra lone pairs, the bonds would be slightly closer together and the angle would be 104.5. So over here, it's 104.5, CO2 is 180, and BF3 was, we already calculated that was 120. This one, we've already done this. So this is 107. This is 109.5. This one is 180. So this is the correct answer, increasing bond angle. So this is the correct answer to this question. Is this clear? Is that clear?
Yes,
Okay.
yes.
Achha, then you have
so H2O का bond angle क्या होगा?
104.5. this one. ठीक है? ये जो सारे ना, they're derived from the, I mean, the first one is tetrahedral, ठीक है? NH3 is derived from a tetrahedral shape, except that instead of having an atom on one side, there is nothing there. There's just lone pairs, ठीक है? So it becomes a pyramidal shape, trigonal pyramidal. और वो angle थोड़ा सा ना, it gets squeezed. Instead of being 109.5, it actually becomes 107. Water is exactly the same, except that on 2 sides now you've got lone pairs. So because of those extra lone pairs, the angle kind of gets squeezed even more. And now it's 104.5. Okay. So that is H2O. Achha, baki hai ki what is the volume of steam produced when 1 gram of ice is heated to 323 at a pressure of, now this is PV0 nRT question. Okay, by just looking at it, because you have to calculate volume. So that's the only equation that you know for calculating volume under non-ideal conditions. Now, in this case, you have to be very careful. The pressure has to be in pascals. So it would be 101 times 10 to the power 3 pascals. The volume that you're going to get is going to be in meter cube, and we're trying to calculate that. N is the number of moles. So you can find the number of moles because it's 1 gram of water. So 1 gram mass divided by the molar mass, which is 18. So that would be N, 1 over 18. Okay, 18 is the MR of water. And so it's PV is equal to N. R is 8.31. That's already given in the data booklet. And finally, you have T. This temperature must be in Kelvin. So it's going to be 323 plus 273. So it's a simple equation, but you have to get the units correct. All your units have to be exactly the same pascals, meter cube. This is moles, 8.31, and this is in kelvins. Now, if you calculate this, can somebody do this? You'll get the volume. And make sure don't get things wrong on your calculator. I mean, if you reach this point, just be very careful with your calculator. So I'm just going to, can anyone try and do this very quickly? Okay, I'm just opening my calculator. That's 323.
2.72.
So you're getting
2.72 into 10 raised to power minus 3. C.
Nee, but that is meter cube. Acha, theek hai. So how do you convert meter cube to dm cube? You multiply by 1000. And that would give you in dm cube, that would be 2.7 dm cube. ठीक है, बिल्कुल सही है. So remember the conversion as well. cm cube to meter, cm cube to dm cube to meter cube. This is divided by 1,000. This one is also divided by 1,000. If you want to go back, it's going to be multiplied by 1,000. So it's going to be C. फिर next पे आ जाते हैं कि we have और किसी को कोई प्रॉब्लम मेरे से पूछ ले, ठीक है. If you have any, if you don't have any issues with the previous questions, ठीक है, do ask me. Solid carbon dioxide is similar to iodine in its structure and properties. Carbon is group 14. SiO2 is group 14 compound also. Which statement about solid CO2 and solid SiO2 is correct? दोनों के structure में one of them is a simple molecular structure, which is okay, you've got a CO2 molecule, you've got another CO2 molecule. So ye independent molecules are simple molecules. They just have weak van der Waals forces between them. Temporary dipole induced dipoles, that's it. So which is why carbon dioxide is a gas. The molecules are freely just roaming around. कोई किसी को रोक नहीं रहा, ठीक है, इसने इधर जाना है, इसने इधर जाना है. They're just randomly moving around because the attractive forces are almost non-existent. They're just weak van der Waals forces. SiO2 का जो structure है, that's a giant covalent tetrahedral structure. Every silicon atom is making 4 bonds with oxygen, and then you've got oxygen atom making bonds with silicon. वो silicon फिर आगे शुरू हो जाता है, it makes 4 bonds with oxygen. So the structure just keeps on going on. It's a giant covalent structure and it's just a lattice. So both solids, अच्छा sorry, उसने ना solid carbon dioxide का है, ठीक है. So the first one, solid carbon dioxide would be कि in solid carbon dioxide, lower temperature where the carbon dioxide would be, I mean, the attractive forces would be stronger and they would be forming a lattice. So I think bari kar lete because they're both solids. Solids always have a lattice structure, ठीक है. Both solids have a simple molecular structure. The only one of them has a simple molecular structure. ठीक है, one of them, तो option B is incorrect. ठीक है, पहले वो incorrect check कर लेते हैं इसमें, क्योंकि that is simple molecular, this is giant covalent. Every atom is bonded to every other atom. अच्छा, both solid have atoms joined by single covalent bonds. That's not true. You've got double covalent bonds over here. So this one is also incorrect. And both solids change spontaneously to gas at STP. This sand, SiO2 is sand. I mean, ये तो spontaneously, it has a very high melting point. तो ये भी गलत है. Carbon dioxide obviously has weak intermolecular forces. Those they can be easily broken. So the first statement is correct because all solids, they have a lattice structure. That मतलब solids जो आपने always में पहले chapter में पढ़ा था, which is कि they've got a regular, nice, neat, regular arrangement. So even if carbon dioxide is a solid, it's going to have a lattice structure. It's going to have all the carbon dioxide particles would be tightly packed, close together. SiO2, the वैसी by default lattice structure, they're all tightly packed, they're all bonded to each other. So the first statement, option A, is correct in this case. As the next one is, okay, you've got an article in Science Magazine, वो कह रहा है कि the following statement, it is lighter than a feather, stronger than steel, yet incredibly flexible and more conductive than copper. Which form of carbon is being described? नहीं, कौन सा? अच्छा, this one. Can anyone tell me which form of carbon is this one? Hello, can you hear me properly? Yes.
Yeah. I think it's graphite, maybe.
No, not graphite. But lighter than a feather, that's graphene. ठीक है, let me just, ठीक है, that's graphene. Let me quickly tell you, go through these structures. इधर मैं कर लेता हूँ. ठीक है, just 1 second. कि carbon allotropes. I mean, you should know about each one of them. ठीक है, about carbon allotropes. तो यहाँ पे ना सारे दिए हुए हैं. So I'm going to go through them one by one. The first one is diamond. Okay, so that's pretty obvious. कहीं पे ज़्यादा एक second, let me just see if there's a better version. अच्छा ये कर लेते हैं. अच्छा, so this one. Now, allotropes of carbon. This one is graphite. You know about graphite. You've studied this all your life in O levels as well. There's sheets of carbon bonded to each other in a trigonal, planar, or hexagonal arrangement, and sheets have weak van der Waals forces. Now, and this is diamond. Every carbon atom is bonded to every other carbon atom. It's a tetrahedral structure. Now, one thing about graphite is that you can, I mean, this was done just recently. What they did was, okay, they were able to remove just one sheet or isolate one sheet of graphite. That is known as graphene. This is what they're talking about. This is lighter. This is really strong. It's a very strong sheet, a very thin sheet, lighter than feather, very strong. It's it conducts electricity really well, and so it's got lots of properties. And this single sheet of graphene, can be rolled into a tube-like structure. Those are known as nanotubes or carbon nanotubes, or there's a word that's used, CNT, that's an abbreviation, carbon nanotubes. And this same sheet could also be rolled up into a ball-like structure. That's known as a fullerene. So just recently, this is what nanotechnology is, that right at the atomic and molecular level, you're able to make structures, tiny structures, which can be used for many different things, especially in medicine delivery, in imaging, etc. So this is what graphene is. So all these properties that he was describing over here, okay, let me just clear this. That it is lighter than a feather, stronger than steel, yet incredibly flexible and more conductive than copper. It's also very flexible. If you take out one sheet, it's like a page, it's like a copy, like graphite. Like graphite is pages in a copy stacked on top of one another. When the pages are stacked on top of one another, they're not flexible. If you're able to take out one single page, then that single page is really flexible, and that could be molded into different types of structures. Okay, like you tear out a page from a book, you can make airplanes out of it, you can roll it into a tube-like structure, but you can't do it with the entire book, because if they're stacked on top of one another, the flexibility is lost. So graphene is very, very flexible as well. So you just need to know some general knowledge about this. Now, so that is graphene. The next one is, which equation has an enthalpy change of reaction which corresponds to the standard enthalpy change of atomization of chlorine. Atomization of chlorine is, by definition, you make 1 mole of chlorine gaseous atoms from its element in its standard state. Now this has to be 1 mole. The element must be, okay, so it's going to be, the element is Cl2. What is the state of Cl2 at room temperature? It's a gas, and it's going to be half Cl2. Okay, it's going to be, the element forms atoms, gaseous atoms. It has to be 1 mole of gaseous atoms. The element is Cl2 and it is gaseous, so that would give you A as the option. Okay, is this clear? So remember what atomization is. 1 mole of an atom is formed from its element, and the element must be in its form that it exists under standard conditions, room temperature. So it's Cl2 and Cl2 is gaseous, remember that. If it had been Br2 is liquid at room temperature. If it was iodine is a solid at room temperature.
Sir,
Yes.
you have written half Cl2, so like half Cl2 is like standard at a standard state, like the
half Cl2, forget half Cl2. Cl2 is not this. I mean this is Cl2.
Yeah.
Half is for balancing. It's half moles. ठीक है? मतलब एक मोल में बहुत ज़्यादा atoms होते हैं. ठीक है? That's a lot of atoms. So it's just half. क्योंकि the product must be 1 mole at all cost. So it has to be half.
Okay.
So next one is question number 11. It's about calculating the value of the equilibrium constant Kc. So iske andar what you do is, the first thing is you've got a container, and this is the reaction that's going to happen in that container. The initial state of the container, what did you add in the container? So the first thing is what's present in the container initially. So what did he add? He added 2 moles of hydrogen and 3 moles of iodine. So there are 2 moles of H2, and I mean this 2 moles and 3 moles. These are what have been added into the container. And so there is no HI initially. He didn't mention any HI, so that means there was absolutely no HI present at the start of the reaction. And obviously a reaction would start, like if you mix I2 and H2, they're going to start reacting with each other and they're going to start forming HI. So the amount of H2 and I2 would decrease because they're going to react, and the amount of HI would obviously increase. Eventually an equilibrium would be established. At the very start, some forward reaction might be taking place right at the beginning. And the amount of HI would increase, the amount of H2 and I2 would decrease, and then an equilibrium would set in. Backward reaction would also start. And when that starts, so both forward and backward, and equilibrium is reached, that means once equilibrium is reached, the amount of moles would stop changing. So the container had a fixed volume of 1 dm cube, and now he says when you opened the container at equilibrium, there were 2.4 moles of iodine present. So this is the situation at equilibrium. Once backward and forward reaction rates became equal, and then when he opened the container, he found out that there were 2.4 moles of iodine. So your starting point was 3 moles. And now what you have is 2.4 moles of iodine. That indicates that 0.6 moles are missing. And that indicates that 0.6 moles must have reacted. So they took part in the reaction because your container had 3 moles initially, now you've got 2.4 moles. So this indicates that 0.6 moles are missing from the container. So they've reacted. One reacts with one. So that means if 0.6 moles of I2 are reacting, then at the same time, 0.6 moles of H2 must have reacted as well, because they react in 1:1. So that indicates that you had 2 moles in the container, 0.6 are gone. So what are you left with? You're left with, if you remove 0.6, you're left with 1.4 moles only. And if 0.6 react, if 1 I2 reacts, 2 HI are produced on the other side. So if 0.6 of I2 and 0.6 of H2 are reacting, that means double the amount, which is 1.2, are getting produced. So initially you didn't have any HI, now 1.2 moles have been produced. So at equilibrium, you will have 1.2 moles. So those are your equilibrium moles. We've gotten our equilibrium moles now. Okay, so the only trick is you just need to find out what quantity of I2 or H2 or HI is reacting or getting produced. So the only thing you needed was this information. You started off with 3, you ended up with 2.4. That means 0.6 have taken part in the reaction. So if 0.6 are reacting with 0.6, on the other side, they're going to produce 1.2. So यहाँ पे moles ज़्यादा हो जाएंगे because 1.2 are getting produced. And over here, the moles would decrease because 0.6 moles are getting used up. So you have your equilibrium moles. And you convert those moles into concentration. He's given us the volume as well. So concentration is moles over volume. So dividing by 1 in this case is kind of pointless. You get the same thing. And then you use these values in the expression for Kc. The Kc expression would be product concentration, which in this case would be HI concentration, and that's going to be squared, divided by the concentration of H2 and I2. So it's going to be 1.2 squared.
0.4.
But that is not an answer. At the bottom, it's going to be
0.4.
This one?
C. Yes.
So it's going to be product concentration divided by your reactant concentration. So you have your answer, which is, so just remember, in your KC questions, all you need to figure out is what quantity is being reacted or getting produced. If you're able to find just one value, you can figure out the rest. 0.6 taking part in the reaction, so that it would react with 0.6, 1:1. And on the other side, 1.2 is going to get produced. So next is question number 12. Now over here is saying consecutive elements X, Y, and Z are in period 3 of the periodic table. Elements Y has the highest first ionization energy. So this is all about period 3. So what you're looking for is the first ionization energy, the middle one, the Y, that's the middle one. And these are consecutive elements. So they must be in period 3, they must be in a straight line next to each other. So the middle one has the highest first ionization energy and the lowest melting point. So for this, I'm going to plot two graphs. One of them would be the ionization energy graph. That kind of looks like this. Just a second. So let's go with this. Ionization energies tend to increase. There's a dip at group 3, then they increase 4, 5, then there's a dip at group 6, and then you've got 7 and 8. So that's how your ionization energies across a period look like. What about melting points? Let's just quickly sketch the melting point graphs of period 3 elements. Remember, this is inorganic. So Na has kind of a low melting point. Then you've got Mg and Al, they almost have similar. Then you've got silicon. And then you've got phosphorus, sulfur, then you've got Cl2, and then you've got argon. So this is Na, Mg, Al, Si is giant covalent. You've got phosphorus, P4, you've got sulfur, which is S8, you've got Cl2. I mean, let me write the formulas as well. And this is argon. So which is it's supposed to have the lowest melting point. So in my opinion, it's probably going to be phosphorus because consecutive elements. Like if you go for silicon, phosphorus, and sulfur, so phosphorus would be the middle one, and it has the lowest melting point out of the three. Silicon, phosphorus, and sulfur. So the middle one has the lowest melting point. But does it have the highest ionization energies? So this is silicon, this is phosphorus, and sulfur group 6, you get a dip. So that the middle one also has the highest ionization energy. So the middle one was supposed to have the highest first ionization energy and the lowest melting point. I mean, you have to memorize the melting points. You must also know what's the factor. The first two are metallic. Sodium is a weak metallic lattice. Its melting point is pretty low. It's less than 100. Silicon is a giant covalent structure. All of the rest are van der Waals. They're simple molecules, but sulfur is S8, so it's got a big molecule, so which is why it's a solid. The van der Waals forces are larger. Cl2 is a small molecule, so the van der Waals forces are lesser, and argon is the smallest of all of them, so it has the least van der Waals forces. Anyways, the answer for this one is option D. Is this clear?
Yes, yes.
Yes, sir.
Assessment 13. I've got, when dealing with spillage of metallic sodium, it is important that no toxic or flammable products are formed. Which material should be used if there's a spillage of metallic sodium? The first one is definitely wrong, because you do that, it's going to be an explosive reaction. So, so no toxic or flammable products. H2 gas would be produced. That would be very flammable. The same would be true for ethanol as well and water as well. Like ethanol reacts with sodium, but very slowly. Alcohols are kind of slightly acidic. They have this tendency to lose the H, but the tendency is very, very small. It's even less than water. So a salt would be produced, and the H that is displaced would be forming H2 gas. It's going to be a very slow reaction, but a flammable product would be produced. Same is the case with water. Metals react with water, and sodium would react explosively with water. It's going to form NaOH plus H2. So the obvious answer is sand. Use sand. Sand is not going to react. So no toxic or flammable products are going to be formed with sand. Chlorine gas is widely used to treat contaminated water. Which species present in water when chlorine gas has been added is responsible for killing bacteria? So it's this one. When you add Cl2 as a disinfectant to water, two acids are produced. One is HCl, and the other one is HClO. So this one over here is the one that is responsible for killing bacteria. It's HClO, hydrochloric. It's chloric 1 acid, HClO. These two ions, I mean, Cl minus 1 doesn't really do much. So it's HClO contains OCl minus 1 ions. Now the next one is which row of the table is correct? Shape is talking about shape. We did this. Ammonia is pyramidal. It's got it's like a tetrahedral, except that the tetrahedral has the top missing. Instead, in its place, there's a lone pair. In NH4 plus 1, that would be regular tetrahedral. I mean, the first two are correct because you're going to get a fourth bond on the top. And that fourth bond is going to be a dative bond, where both electrons are provided by N, but it's like any other. It's going to be like any other dative bond. And all the bonds are going to be sigma bonds. I don't think there is any pi bond because all single bonds. Remember, whenever you have a single bond, that is by default a sigma bond. Double bonds only appear if you have, pi bonds only appear if you've got a double bond. It's going to have one sigma. The first one would be sigma. The next one would be pi. If you have a triple bond, then the first one would be sigma. The rest of the two bonds are going to be, they're going to be pi bonds. So this would be A. They all have sigma bonds. Next one is you've got hydrogen chloride gas and hydrogen iodide gas have different thermal stabilities. Can you even quickly tell me which one has the stronger bond? Zahib, any ideas?
HCl.
HI.
Remember smaller atoms?
HCl, sorry. Yeah,
HCl. So remember the smaller atoms, they always make stronger bonds because they're closer together. There's more orbital overlap and the bond length is also smaller. So they attract each other more strongly. So identity of the most stable compound, that's going to be HCl. So it's going to be either A or B. And the explanation is that HCl bond is stronger than HI. So that's pretty obvious. So it's going to be B. Now you've got ammonium sulphate and ammonium nitrate are used as fertilizers. These salts have different percentages by mass of nitrogen. They have the same effect as each other on the pH of the neutral soil. So which row is correct? So higher percentage. So you can just make a rough guess. This one has 2 nitrogens, so that's 28. And the overall MR is what? 28 plus 48. I mean, it's 28 plus 48. I mean, 3 oxygen, that's 48 plus there are 4 hydrogens. This one would also have 2 nitrogens, so that's 28. Plus NH4 is 18 plus 18, that's 36. Plus sulfur is 32 plus 16 times 4. So I think, I just suspect that this one is, this one has a greater percentage. You can do your calculation. It's going to be NH4 NO3. I mean, that's my hunch. You can do the math. What would be the effect of NH4 plus 1 on the pH of the soil? Now, NH4 plus 1, remember, is acidic. It's a conjugate. The term is used. It's a Brauset-Lowry acid. because whenever something has NH4+1, it's capable of producing ammonia gas and losing an H+1 ion. So it's going to increase the quantity of H+1 ions that are present in your solution. So it's going to become more acidic. So the pH of the soil is going to decrease. I mean, you can check the first one yourself, but remember, ammonium ions are acidic. They release H+1 ions, and which is why the pH of the soil is going to decrease. The next one is the river water contains these ions. And what will be precipitated from the river water following the addition of calcium hydroxide? So if you add calcium ions as well, now the answer is simple. What is a precipitate? It's something that is insoluble. Only those things form a precipitate that are insoluble. If you know the solubility table, nitrates are never going to form a precipitate. Nitrates are always soluble. Chlorides are also soluble, always, except for silver and lead and mercury. So this is also soluble. The only one that's not soluble is calcium carbonate. So that's the one that would be forming a precipitate. Is this clear?
Yes.
Okay. So then you've got the next question, 19 is, okay, what is the function of the thiosulfate ion? This one. Now, and I'm just going to answer this directly to make the silver ions more soluble. I'm going to explain